This video shows how multiple computers can communicate with each other, that is, send and receive messages to each other, using something called MQTT. In doing that, it will show you a Python module called simpleMQTT that you can use to make your Pygame projects have multiple computers that communicate with each other. Let's start with an example. So I've set it up so that over here, one copy of the program is running. We're imagining that that's on computer 1. And over here, another copy that we're imagining running on computer 2. In fact, they're both running on my computer, but it would look and behave identically if we in fact ran this on two different computers. So over here it says enter your chat friend name, so I'll put in Alice. And over here I'll put in Bob. And in both cases it says to do messages. So this is a chat example. So over here Alice will say hello, and see it says, Alice says hello. And then how are you? So when this program, this run of the program says how are you, this one over here echoes that, saying Bob says how are you. So you can see that what's happening here is that the messages that are being typed on one computer are making their way to the other computer, or what we're imagining is the other computer, and then getting printed there. So that's showing you that we can both send and receive messages. Now let's talk about the big picture briefly, and then we'll see the code that you will use that is very simple to achieve this and other programs like it. Let's briefly talk about the big picture. That's this thing here. The goal is computer-to-computer communication. So we need some sort of agreement, what we call a protocol, for how the computers will interpret the zeros and ones that come through the physical lines from one computer through the internet to another one. The solution that we're using here is something called MQTT. It is a protocol, a way of interpreting the zeros and ones that is widely used. It's become the standard in what's called the Internet of Things. All those devices in your home, on your phone, everywhere else that are very tiny computers that sense things or do whatever. So, for example, maybe you have a fire alarm detector, maybe you have a fire detector. For example, maybe you have a smoke detector that's connected to the internet, and if your house were to catch on fire, it would send a message from the device to your phone, for example. And then your phone might send messages to other people on other computers to help them out. That's the kind of thing we're talking about. Now, so it's called MQTT. The basic idea for this and for the Python implementation of MQTT that we'll use, called PahoMQTT, is that there's this thing called a broker. A broker is just a computer running in the cloud that has agreed to run code so that messages can come to it, and it will then forward those messages along. So, for example, our smoke detector might publish a message saying, no fire right now, and the broker will forward that, that's the purple, to the various things that have subscribed, that's the word, subscribed it via, and that's shown by the green arrows. So publishing is sending messages, subscribing is saying, I want to get those messages. And then there's a concept of a topic that says this one's going to publish on a topic, and that's what determines when this one subscribes to the same topic, what messages go where. So again, there's a broker in the middle, computers send messages to the broker forwards those on to anyone that is asked to receive such messages. So that's the theory behind, but you don't need to know any of that. All you need to know is that your program will have a sender and a receiver. And as you'd expect, the sender can send messages, and as you'd expect, the receiver will receive messages. There may be some programs that only send, that's the example here, but in general, they have a sender and receiver. So your code will be almost as simple as construct a sender, construct a receiver, make them start running. We'll see the details coming up. I'm going to show you two examples. One is the chat that we just saw. You'll see the code for it in just a moment. And then another one, the next one, will be a Pygame example where two Pygame programs are communicating with each other. These examples and the code that you need is in your 99A Pygame API tutorials. So if you look at that, you've already noticed you have a moving smile and other things there. Well, now, if you do a VCS update project, you will see that in that 99A folder, you now have an 07 multiple computers. And it is the code, simpleMQTT. That's the module that you'll import to do your stuff. And then there's a chat example and a Pygame example that we're going to go through. So again, that's in your 99A folder in your own repository, and you can obtain that by doing VCS update project as usual. It's in the 07 multiple computers. So let's see. Here's the M0 example. Here's the code. Before I show you the code, I want to show you how to run it. In real life, you would run this here on two computers. So you would run it in the usual way here, run simplest example, and your friend on another computer would run the very same program with a slight change, I'll show you that in a moment, to have it run on their computer. And the two computers will talk together, and we'll see exactly how it is that they know to talk to each other and not to other computers. So in real life, you'd run this on two computers. But it is much, much easier to do your testing and debugging on one computer. Luckily, that can be done easily. And if it works on one computer, as I'm about to show you, you can feel very confident it'll work when you do it on two different real computers. So the first point I want to make is that we need to make a change. Let's see here. First, we're going to run in the usual way. So there it is running over here on the right in the usual way. That ran down here as if that were computer 1. I'm now going to change that 1 to a 2 and run again. You'll see though, let's see here. I have to do something real quick here. Okay. So now I'm going to run with computer 2, and you'll see that when I do so, something happens that doesn't work. It says it's not allowed to run in parallel. To make it run in parallel, what I have to do is select the file, so I'm clicking in that window, going up to Run, Edit Configurations, and then in that thing that will pop up in a moment, so here it is, Run, Edit Configurations, I check the Allow Parallel Run. I check the Allow Parallel Run. And you'll need to do similarly on your computer when you get ready to run these things here shortly. So I've set that up. That's a one-time setup. Now I can run the code a second time. Remember, the first was with main calls main with 1. This second one calls main with 2. And so now I have, let's see here, 2 runs. There they are there. The one run and another run. And this one here, I could enter in Alice, and it connects up. This one here, I just went to the different tab, and I put Bob, and I can now, in this one, start saying things like, hello. And hello in this one got echoed on the other one. So this is sending information from this computer running the program to what we're thinking of as a different computer running the same program. This first one sent a message, hello. This second one received a message and printed it, saying Alice says hello. The communication can go the other way as well. So here is Bob saying to Alice, and then this one here receives that message. Now, the two-tab approach works fine and is the simplest thing to do, but you can't see them both at once. You can't see the consoles for both of these at once. There's a way that we can make that happen, so I'm going to redo this so I can see this console, this output, and at the same time see this one without having to switch tabs. To do that, let's see, I'm going to kill these things, so I'm going to stop them both. Don't forget to kill your programs or you'll have a lot of things running. And what I'm going to do is I'll close those back to where I was. So I'm going to run the first one. So this will be with main, we'll stick with 2 here in the usual way. It goes off here to the right. So that one's good. For main 1, for the other computer, I'm going to run as a debug. So I'm going to run debug, not run, but debug. That's because debug shows up in a different window. Now for you, it probably will have shown up, let's see here, probably will have shown up over here. This is probably what you will see the first time. So here's the debug window, and back hidden is that run window. What you'll need to do then is go up to the little gear symbol, move to, and move, say, the debug one to the left top. So I just moved it. So here's the debug window. The run window is still there. It's just minimized. It's just minimized. I just click on that. So I've just done that. And here is the run window. So I've now got my 2 runs. This one over here that we'll use as Bob, and this one here, which we'll say the friend's name is Alice. So here, when I type hello, it just shows up right over there automatically. So how are you? I am fine. This is all what Alice saying stuff to Bob. Over here, Bob can say stuff. And so there's Bob saying stuff to Alex. And we can just click in one, press enter, click in the other, press enter, and they go back and forth. So by setting one to run via run and one to run via debug, we can arrange for the 2 windows to be visible side by side. You could try this if you'd like at this point. Let me just summarize real quickly again what I just did. But be aware that if you try it at this point, and any other students in the class are running the same demo at the same time as you, you're going to get their messages too. So let's just show you what I've got here. There's a little red square up there. I'm using that to stop them all. And I'm going to take here and remove them from the sidebar just to make these things go away so it's like it was. And then I'm going to click over here for your project. So this is the way things probably look for you at this moment. Again, the way that you run 2 side by side is, first of all, you have to click in there, come up to the Run menu, which is up top there, the Run menu, and then Edit Configurations, and check the Allow Parallel Run box. So you have to do that on this program. Then, and you'll have to do that on any program you run. We'll have to do it again when we get to M1. And then I run one, and that will appear off to the right here, if that's where you've set it up, or the bottom, or wherever it is you've set it up. Then you run in debug. So you debug it instead of running it. And that will appear initially on the same place as the other one, but you can use this and move it somewhere else that you like. I like one on the left top, one on the right top, but entirely up to you. Alrighty, so feel free to pause the video at this point if you'd like and run and check that it all runs okay for you. If anything is going wrong with your stuff with regard to this video, of course, just check in with me, David Mutchler, and ask any questions you like. Of course, if anything is going wrong, check in with your instructor, or this term with me, David Mutchler, if you have any questions about anything here. I'm going to continue now by showing you the code. So let's do that. I'm going to stop all my runs. So there's a little red square up there I clicked on, stop all. I can either drag these apart, or in my case, I'm just going to make the project show up. There was there. Click there. Brings back my middle window. I'm going to make that big so that we can all see the code. And we're just going to walk through that code. As I do so, I'm going to be saying some things, and pretty much everything that I said is written down here at the bottom of this file via these notes. So everything that I'm about to say, first of all, I'm going to show them here on the screen, and also when you look later, you can see them on your own computer. Alrighty, so here we are. Let's see. The up here just says that it's a chat program. It's not a very good user interface. We'll do a Pi game one that's better. The video shows you how to do things, but briefly, chat. It's licensed via what's called a Creative Commons license that allows you to share with any organization that agrees to keep the same license here and to not use it for commercial purposes. And you can look that up there if you're curious about that. This example uses the time module and this simpleMQTT. So that's the one here that you'll need. So you'll need to have this module in with your code to make all this work for you. Now, I'm going to import simpleMQT as MQ. So later in this code, we'll see MQ dot stuff. The first thing I want to show you is what I'm calling a controller class. You can call it anything you want. It does not have to be controller. But what is required is that you have a class that has this very specially named method, actOnMessageReceived. And that specially named message, which must be spelled exactly like that, takes, in addition to self, a message, which is a string, and a sender ID, which here is ignored, but is the number corresponding to the computer that sends a message. So as we're about to see, when this program is running, something will be running in the background, and whenever that thing running in the background gets a message from another computer, it's going to call actOnMessageReceived for your controller object. Yours does not have to be called controller. You can call it whatever you want. It can be a player, whatever you think, whatever fits with your thing. And then when messages are received, this specially named message runs. Again, to repeat, it's got to be spelled exactly like that. It's got to have self and two other arguments. This no inspection just is a message to PyCharm saying, yeah, I know I'm not using this ID. So there's an unused local sender ID. Yep, that's true. In this particular program, I'm not doing anything with that sender ID. Maybe in your programs, you care what computer is talking to you, and then you'd want the sender ID. So that's note one. Let's see if there's anything else I should say. Again, you've got to have an object to receive messages. The object must be an instance of a class that has that method, spelled exactly like that with self, message, and sender ID. That method can do whatever you want. Here, all it does is print whatever the message is, along with the name of friend that was established when this controller object was constructed. You don't have to call it controller. You do have to have an actOnMessageReceived. Your init doesn't have to take arguments, or it can take multiple arguments. It can store whatever it needs. But what's needed is the actOnMessageReceived. All right, so that's note one. So when you run this, you're going to run it on two computers. And on one of them, you're going to call main with the argument 1, and the other main with the argument 2. So way down toward the bottom, it says main 1, and it says when you're running on the other computer, use main 2. So that's how the two programs can distinguish each other. They're the same program running on both computers, except one is running with whoami being 1, the other is running with whoami being 2. If you accidentally run main 1 twice, that would make that one thing try to talk to itself. Messages are never sent to itself, so nothing's going to work right. So you need to just make sure that you run main with an argument 1 and then main with an argument 2 for the 2 runs you're running. This program then goes ahead and gets some information, the name of the other chatter, just because that's what this program wants to do. And then we have these 5 lines. These are what, along with a little bit else, makes the communication happen. So again, so far we've seen 2 things. One, that you have to have a class that has an act on message received. And then you're going to need these 5 lines. Now, this part here has to be a unique ID. I'm using David Muchler example 0 with the CSSE 120 in front. Anybody else in the world that is running this program with that ID is going to have messages sent to it, and that computer will send messages to me. There's no password or anything remotely like that. You can make passwords, but we're not going to bother. We're just going to make this unique. So you should make this your own name, whatever you want. So Bob and Alice. It just doesn't matter. Make it your username. So maybe I put Muchler here. Whatever you want, but pick something that you and your team members, which will use the same unique ID, are doing something that nobody else in the class, or hopefully nobody else in the world, is going to be using. So I'm going to return that. Well, I'll leave it as Muchler here. So the first line of code is the unique ID, and again, you need to set that unique ID to something that is unique to you and your team members. The next line is you construct an MQ sender. The MQ sender needs to have that who am I, and that's how it knows whether it's computer 1 sending to 2 or computer 2 sending to 1. You then need to make a controller object. That's this thing up top here. Here's the controller. Note that, so we're in note 2 here. Note that the controller, again, can be any class name you want, and it can take whatever information you want here. So this is taking the name of the friend and that was set up here. But you have to make one. And then when you construct your receiver, you have to give as an argument that object that you constructed that we're calling the controller here that has an act on message received. So again, you need to make your own unique ID. You then construct a sender with the who am I 1 or 2. Then you construct your own object. I'm calling it controller. You can call it what you want, with its own data, anything you want there. But that object has to be sent as the argument to the MQ receiver, which I'm calling receiver. Finally, you do the MQ activate function, which takes the unique ID, the sender and receiver, and that causes the message passing to actually start. Underneath, it's connecting up to the broker and doing that stuff, but you don't have to know anything about that. You just have to believe that you got to construct a sender, you got to construct a receiver. The receiver needs an object that has an act on message received. You better have a unique ID. The sender needs to know whether it's 1 or 2. The code actually works with more than 2 computers, but this is a 2-computer example. And then after you've done those 4 lines, you activate with the ID and the sender and receiver. And that starts the communication occurring. So that's note 2. Let's continue on. Note 3 says something about the senders. Here's that sender again. It's verbosity and the receiver's verbosity. Now, right now, I've set it to 0 for the examples I just ran, but your code starts out with it as 3, and you should leave it at 3 because that produces debug messages. If you go to 0, you won't be able to see what's getting printed. You won't be able to see what messages are going from one computer to the next, and you'll have a real tough time debugging. So you're definitely going to want to leave this as 3, which is the form that it came to you in. Let's just quickly run to see what that does. So again, I'm running once there with main 1. Doesn't matter which one's 1 and which is 2, just matters that I have both. All right, so I'm going to run with main 1, and that starts that one up. And then I'm going to debug with main 2, and that starts that one up. And then I'm going to say that this is Alice, and I don't know, let's let this one be Gamma, just for funs. And now when I type a message like hello, how are you, it echoes back here that computer 1 is sending to all the other computers, hello, how are you. This one says it received by computer 2 from computer 1 that message, and then this print was what the program itself did. So this right here and this right there are being printed by the underlying simpleMQTT, just so that you can see that the messages are really getting sent and messages are really getting received and what the messages really are. So you'll want to leave debug the verbosity set to 3 so that you get those messages. Just to show you some more, here it is doing that, so that if your program is not acting correctly on those messages, you can tell that at least it sent it, and at least it received it, and here's what it received. So if that were bad input, bad thing to send, and your program does something, you can tell that it got sent there, but just didn't do the right thing. So bottom line, back to where we were, leave the verbosity set to 3 until you get to your final version of your code, in which case you can set it to 0 to get rid of those debug messages. So that was note 3. Note 4 says that we're just entering what we might call the game loop here. This game loop repeatedly gets an input from the user, takes that sender, there's the sender, and calls its send message. So if over here we were to type sender dot, let's do it, it pops up that you can send message. You could also do some other things, but that's really the only thing you're interested in with the sender, is to send a message. So that's the MQTT protocol allowing you to send messages. And let's see. Again, note 5, you run one program with main 1, then you run the other instance of the program with main 2, same program other than that. And I think the only thing that I didn't say in all this is that when we do activate, something important happens. Namely, there's a background process set up. So running in the background after activate is the receiver listening for messages. So even though there's no mention of the receiver down here, while this loop is running, in the background, this receiver object is listening for messages. And whenever this receiver object receives a message, in the background, the simpleMQTT code calls controller dot act on message received, sending it the message and the number that identifies the computer sending it. Let's try to summarize again. For you to use this in your code, you've got to make a class that has an act on message received method that takes self, message, and sender ID. You can call the class whatever you want, it can store whatever information it wants, and it can do whatever it wants with that message. You also have to have these lines here that set up the message, the communication with a unique ID, so change yours to something unique to you. Other than that, these will be verbatim the same for you, except you don't have to call it controller, and your controller will have different information than what this one is storing. Keep the verbosities at 3. The activation just above, this activate, enables the sender to send messages. So anywhere in your code you want to send a message, you just arrange for that sender to get to that place in the code and you call send message, you put any string you want there, and it'll get sent. And then also in the background, the receiver, by virtue of the activation here, by virtue of activate, the receiver is receiving messages, and when it receives a message, it will take your controller object with your data stored with that object and call its act on message received. Well, I'd like to stop and take questions, but I guess that's difficult to do. So, yeah, so that's it as far as chat's concerned. I'm going to do one more example, but really that's all that we have to matters. Again, if you have questions about any of this, please contact either your instructor or in this first term, me, David Mutchler, with questions. I'm going to do one more example. I'll try to go through this one a little faster. Let's see. Let's first come back to here and stop my things that are running. And I'm going to go back to the code. And now I'm going to do a Pygame example. This example has notes at the bottom, just like the other one had. So I'll try to go through this a little more quickly, but everything that I'm saying is written down there. Let's start by running it. For this one, I set up two files. They both import the code proper, but this one calls main with 1, and this one calls main with 2. That just makes it easy for me. I don't have to ever change that call in main. That just lets me run Pygame with the run there, and then I go over here to this one that has 2, and I debug it, and I've now got 2 of them running. Now, I should have paid more attention because one of them is behind the screen here. It's in the background. So I need to find that one. Alrighty, so there's one. There's the other. There's the program running. Now, at this point, they're both madly sending information to each other. You can see that there. It's not easy to see, but it's happening on both of those. And they've been sending a lot of messages. What this one does, though, is when I click in one of these windows and use the arrow key to move the black dot, that's the player. The black dot that I'm moving on computer to is the player. The red dot is what I'll call the zombie. The zombie on the other computer moves exactly as the black dot, the player, does on the first computer. So again, I'm operating over in this computer. I'm moving my player, my black dot, with the arrow keys, and it's sending messages over to computer 2, and those messages are causing the zombie to move to the same place where this one is. Likewise, I can go over to computer 1, so I clicked in there. I'm moving its player around, and it's sending messages back to its zombie. Back to its zombie to make things happen. So there's a bit of a lag. You can sort of see that there. But anyhow, this is showing you how one Pygame instance can communicate both sending and receiving with another Pygame instance where they're running on separate computers. So if you want that kind of activity, this example is going to be golden for you. I'm going to go ahead and stop that example and show you the code. So let's see, I'll go back down to here. There's that box. Stop the things from running. You might hear my screen having turned, my fan turned on in the background. You might have heard my fan turn on in the background. That has the effect that's happening because these processes were so busy. But anyhow, here's the project. Here's the code for this example. And so let's look at that code. Whoops. Here's that code. There we go. Here are the notes. I'll sort of put them over here. But I'm just going to try to go through this one quickly. Much of it's the same as the other one. There's a controller. Again, you can call it whatever you want. This time the controller holds a zombie object that we'll see down below. The act on message received, same as before. But this time it takes the message and decodes it. We're going to talk about that in a sec. And tells self-zombie, tells the stored zombie thing, to move to that XY. Zombie is an instance of the player class. So down below here, we're going to see that there's a move to that changes the player's position, its X and Y, to be just the X and Y that the message says. To decode a message, one way to do it is you put the data separated by spaces. So here they are, separated by a space. And then you apply the split method. So here's an example. If we had the string 138 and we split it, we get the list of those two strings that were separated by one or more spaces. So split splits a string into a list of strings. Since it's a list, we can get its bracket 0 item, that's the 100, or its bracket 1 item, that's the 38. They're strings at that point, but we can then apply the float function to it to change them into numbers. So that's what this does over here. It floats, so it takes the message, splits it, gets the bracket 0 or bracket 1 item, in both cases turns them from a string into a number, here a floating point number, because in this program I'm letting the X's and Y's be floats. I'm not restricting them to be integers. If I restricted them to be integers, I could have put int here, but there's no downside to just letting them be floats. Not much downside. Anyhow, that's what this is. That's what happens here. So that's note 1. Note 2 over here is that when the player is constructed, it's going to have a draw, just like the draws that you have. I'm drawing it as a circle. That draws it at a certain point. And players in my code have a move by arrow keys, and that's the arrow key stuff. You'll see it in a sec. It's just like you're used to. Here, let's look at it. That the same arrow key stuff you're doing. But my player also has a move too that the zombie uses to change the self X and self Y, to change the self X and self Y to whatever they are set to. And that happens when the zombie is moved per a message sent from the other computer. So the idea here is that the player is going to need to when it's constructed, first of all, it has all those things, but the player needs to store the sender, because the player, where's that occur? Down a little further below here. Yes. The player is going to send to the other computer its position, and then that other computer is going to have its receiver receive the message, call the act on message received that we saw up there in the controller. The controller has the zombie. The controller tells the zombie to move to the position that the other computer's player was at. We need to store the sender. In this code, we're going to see that the player is constructed before the sender. So here's the first thing that is novel about this example, different from the chat. This one wants to store the sender because it needs to use it down there. Self.sender equal. Usually we pass them in when the player is constructed. But in this example, it just so happens that the sender is constructed after the player is constructed. So it's impossible to send the sender to the player because the sender doesn't exist when the player is constructed. So the technique we use is we set self-sender to none as a placeholder, a temporary placeholder, and a few lines of code later, when the sender is constructed, we use the setSender method to change self-sender to sender. Note 3 was that there's using the send message. Let's show you what I was just talking about. Let's see here. This is just pointing out that there's two players, a player and a zombie. They're both instances of the player class, but the real player, the black dot, moves with the arrow keys, and the zombie, the red dot, moves via messages. Here's note 4. So again, these are the same 5 lines as we saw before. Here it's using this as my unique ID. You can use different ones on different programs, and if you're going to run this for different programs at the same time, you ought to. But it creates a sender saying, who am I? That was up there in main, the argument to main. Created a controller storing the zombie. Controller has to be sent to the receiver. And in this example, see, here's the player being constructed. The player needs to have this sender because the player uses the sender to send messages. But we can't put this variable sender up here because it hadn't been defined yet. So instead, we do this line down here that I'm doing it after it was activated. I suppose I would have done better to do it just before activating now that I think about it, but this way works too. So activate happens, the verbosity set, and a millisecond later, so it's happening very fast, the player runs its set sender, and all set sender does is change the player's self-sender to the real sender that exists at line 168 and didn't exist at line 148 because it was constructed at line 155. Note 6 is that we enter the game loop, the usual game loop. The player and the zombie are both player objects, so they're both drawn. The player moves by the arrow keys, and in the background, just as before, the receiver is waiting for messages. So when the player, the black one, moves by keys, it sends a message to the other computer saying, I'm at this position, and that receiver running in the background will receive the message, call the controller's act on message received, take that message, which will be a pair of numbers separated by spaces, one or more spaces. It splits it into a list of strings, identifies the X string and the Y string, floatifies them, and then tells the zombie to move there. And that's why the zombie on one computer goes to the same place that the player, the black dot, on the other computer is at that time. Actually, a few milliseconds later, because it's gone through the internet to wherever the broker was, which is, I'm not quite sure where it is, but it certainly isn't Terre Haute. So within a fraction of a second, that message goes to somewhere else in the world where the broker is, and then back to the computer. And so that's why we saw a little lag there. So I hope that this has shown you what you need to do if you want to use this code. Again, it's as simple as having an object that has an act on message received that does whatever you want done when messages are received. These 5 lines, where they go, these 5 lines to set up the message processing. Whenever you want to send a message, you use the sender, which was established by those 5 lines, and hit send message. And in the background, the controller object's act on message received is run whenever a message is received. And again, you can do whatever you want with it. So very little effort on your part changes a one computer, one player game into a 2-player, 2-computer game. Both of them using the same code, just one of them running with who am I being 1, the other running with who am I being 2. And you can have code like this one has that says, if I'm 1, I want to have this initial position, but if I'm 2, I'm going to start out over there. So you can, depending on whether you're 1 or 2, distinguish them on those different computers if that's what your game wants to do. So maybe 1 is visually shown as a enemy and 1 is shown as a hero. Whatever you need, you can do via Who Am I. Any questions? Just contact me, David Butchler.